All right, everybody. Good afternoon. We are starting today. We're moving a little further on in the book. We are now in chapter 16, okay, which is on page 484. We're at 16.1, Human Population Growth and Natural Resources. All right, so we are going to go over the key vocabulary that we have right here. Some of it should be familiar to you from previous chapters, but we're going to go over it again nonetheless, maybe in a slightly different way. The first thing I want to do is bring you down here where we're talking again about carrying capacity. So as we had said in previous lessons, carrying capacity is a maximum population size that a specific environment can support consistently. Remember, if it goes up too high, all right, it could drop back down because we're losing resources, right? The environment can no longer support that size of a population. And then when the resources go down, things die off, population decreases. Now there's more resources available because there's less things using them, population can go back up, and it does that little fluctuation, okay? So if it has a nice constant fluctuation, and let me draw that out here, all right? So we see population rise, it gets too high, drops down, up, okay? That nice average is going to be our carrying capacity, okay? If we look over here, okay, world population, present time, we have currently somewhere more than 6 billion people on this planet, okay? And this orange part, indicated right here, shows a projected growth, okay? So let's think about what are some reasons why population, going back to the 1100s, right? 1150, 1350, 1550. It's a slight growth, but it's pretty shallow, all right? It's pretty steady. It's not dramatically increasing. But then as soon as we get into the 18 and the 1900s, we start to see this dramatic spike, and then around like 1950, boom, it goes way up. All right, so what are some factors that would allow our planet to support way more humans on it than in all of these previous years? Right? To sum that up very generally, we have better technology. Okay? We have better ways of growing food, of getting food, of keeping that food. How should I say this? Keeping the food from spoiling, so we can store it long term. So sorry, storage of food. We have better waste management systems. All right, getting better sanitation, better of keeping things clean, keeping people healthy. We have huge medical advances. All right, people are living a lot longer than they used to. All right, even if you look just a few generations back, the average lifespan has increased from just thinking about possibly like your great great grandparents or great 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 grandparents. Their average lifespan of their generation was a lot less than your generation will probably be. Okay, reasons being is life is getting easier. We're providing ways for humans to get the things they need when they need them, right? In less amount of time, less effort. We are providing ways for humans to get these resources that just nature left alone by itself would not be able to provide. Now, as I just stated, getting these resources and getting what people need has become a lot easier than it has in the past. However, this does exert still a pressure on some of our natural resources. For instance, fresh water. We're lucky we live on a gigantic source of fresh water. Okay, the Great Lakes supply millions of people with fresh water that they need. Okay, we are extremely lucky. Okay, we do not live in an area with very little fresh water. We do not live in an extremely dry climate. We're not surrounded by nothing but salt water. All right, so we have this available water. Okay, some places are not as lucky. Okay, and they have to find that water somewhere. They could dig down into the ground and try to find groundwater, make wells, or they would have to ship their water in from other places. Collecting of rainwater, all right, would be another way to combat, not having fresh drinking water. When we get into this a little later, we'll also talk about how the things we do are actually hurting our freshwater resources as well. So this brings me into the two main types of resources we're going to talk about here. Okay, we're going to talk about non-renewable resources and renewable resources. Now, we had talked about these previously. Let's go into again exactly what they are. All right, so the easiest way to explain this would be non-renewable. All right, so if I'm thinking about something that's renewable, that's something that I can get again and again and again and again. Like, for instance, once I get my driver's license, I'm not going to have to retake that test again. Okay, after so many years, I'm going to have to go and I'm going to have to renew my license. All right, I'm going to have to pay a fee and get my new picture taken and this and that, but I'm not going to have to go through the whole driving school, driving testing again. All right, I've already completed that. I'm just renewing my license, still to show that I am around and I am a capable driver. Okay, I can see the road, I have an address, whatever. Okay, things that are non-renewable are things that expire. Okay, they expire and you cannot get it again. Like, for instance, if you're not trying to trick the system, something like a free trial for something. Now, I know there's ways around it, and I can get multiple free trials of something if I, do this or do that. But in its essence, free trial for something is you get to try something for free for a short period of time, and if you like it, then you can buy it. If not, it goes away. It's gone. Okay? That's like something that is non-renewable, a non-renewable resource. Once you use it, and it's all gone, it's gone. Okay? An example of this, right here, they're talking about oil and coal. Okay? Now, these are non-renewable resources. We do use them for energy, right? They burn. Okay? Now, oil and coal do form again, but they will not form in our lifetime. So in that essence, they are non-renewable. Okay? By the time, if we run out of oil, if we run out of coal or natural gas on this planet, they will be gone. And by the time we have more, humans might not even be a species anymore. Okay? Millions and millions of years. Okay? Millions upon millions upon millions of years to remake these things. Okay? Non-renewable. Once they're gone, we're out. Renewable resources, these are things that can be used again, again, and again and replenish themselves. We are not going to run out of wind. Okay? The wind is always going to blow. The tides are always going to move. Ocean currents are going to be moving. The sun is going to be shining. And if the sun's not shining, then it's been a really, really long time. Okay? That thing's not going to burn out for billions and billions of years. Okay? So once again, we're not going to run out in our lifetime. Okay? These are things that are always going to be available. Okay? And it just so happens that a lot of these things, like wind, and solar power, geothermal power, all right, so using the heat energy that the Earth, all right, actually creates, wind currents, ocean currents, right, we are not going to run out of those things. Okay, we can use them time and time and time again. Right? Renewable, you are not running out of. Right? You can use it over and over and over again. Non-renewable, you will run out. And these are going to end up producing a lot more pollution and environmental issues than if we use these. Right? So going into talks about global warming, which is what we're leading into. The burning of non-renewable resources such as oil and coal, all right, do produce greenhouse gases, which can lead to global warming. All right, so let's take a look at an example of overusing an area's resources. Okay, so here is a picture of Easter Island. All right, Easter Island, that island, you find all these monolithic giant heads sticking out of the ground that were built by the humans that lived there. Okay, now this island at one point was full of thick forests. Okay, it was covered with trees. Um, the people that lived there, all right, cut down those trees for lumber, build homes, build boats, anything they needed. And unfortunately, they were cutting down those trees faster than they could grow back. Okay, so trees are considered a renewable resource because they will grow back, and they will grow back within a reasonable amount of time, a couple generations, not millions and millions of years. But you have to take care of them. You can't cut them down faster than they regrow, because then you will run out. Okay, so if they're not regrowing, and I'm pretty sure the people here were not planting new ones, right? Eventually, this island was left without trees. Now, when a tree is growing, okay, tree here. I don't know why I'm using purple. Okay, so when any tree or any plant grows, okay, you have a root system, right, growing and spreading out from underneath that tree. Now, when you go in and cut that tree down, okay, and everything up here is left dead, the roots are also going to die. Okay, now these roots are really good at keeping the soil, right, where it is. So if there's a tremendous amount of rain and flood water, right, running over the land, okay, so I'm going to draw my water here, right, running over the land, right, maybe there's higher ground over here and it's higher over here and the water's running that way, I don't know. So water running down, okay, what's going to happen is this soil, normally that was being held where it is by these roots, is going to get washed away with the water. So that also limits the ability for new plants and advanced plants, like we talked about in ecological succession, right? Building up those from smaller plants to larger plants, you need that rich soil. If all that rich soil is being washed away, you're limiting what can grow back. Okay? So over time, the trees disappear. The trees disappear, the humans are running out of resources they need, the animals are losing their habitats, they're dying off, right? So eventually you see the human population crash. Either they left, it says right here they disappeared, right? So they either left the island or they died off, but basically this island became quite uninhabitable, right? It could not support the life that was once on it. Okay, here, last topic for this section, ecological footprints. All right, so the Earth's carrying capacity. All right, so how many people can this Earth support is dependent upon how much land is needed to support each person. Okay, so when we're talking about this, all right, so it's the land necessary to produce and maintain enough food, water, shelter, energy, and waste. All right. That is an ecological footprint right here. I'll read it one more time. The amount of land necessary to produce and maintain enough food, water, shelter, energy, and waste is called an ecological footprint. So the amount of land that is needed to support you in every single way is your ecological footprint. Okay? So a lot of people talk about reducing their ecological footprints. Right? So reducing the amount of land that is needed, okay, to support them. And this can come in a variety of different ways. When we're talking about the amount of land, we're not just talking about where you live, okay? We're talking about the amount of land that's needed to, obviously, house you, the the amount of land needed for all the things you do, the places you go, the job you do, the school you're in, okay? But also the amount of land needed to make your food, right? Grow your food, raise your food, right? So we're talking about livestock, we're talking about vegetables, fruit, okay? How much water you're going to need, okay? What land is that water coming from? So where's that water coming from? The energy, right, needed to support you. So if you're just talking about your house, I mean, it's going to run probably on a combination of electricity and natural gas. A lot of people also have solar power, which reduces their ecological footprint. Um, Natural gas and electricity, all right, are going to be coming from somewhere. Okay, there's going to be a power plant somewhere producing this energy by a variety of different means. It could be a place that's using non-renewable resources, okay, which is also probably taking resources it needs from other areas of land. So, for instance, if there's electricity produced by coal, the burning of coal, you have to dig into the ground somewhere else, mine for that coal, find it, all right, transport it, right, which is also using gasoline, which had to be found somewhere else, right, to that area, and then is any land being damaged in the process of using this energy? Is any land being damaged in the process of finding this energy, or transferring it into electrical energy? And then the waste products, all right? So this goes from something as simple to understand as the stuff you throw in the garbage can to the waste that comes out of your house and is managed by waste management systems, like, for instance, the water sewer lines, and water management plants, treatment plants, um, to the pollution that you produce. Okay, the driving of cars, all right, would produce pollution from the emissions, right? Because you're burning gasoline. So one way some people try to decrease their ecological footprint is by decreasing the amount of land that they are polluting, right? By using more renewable resources, clean energy, using basically what nature is already providing, right, as a source of energy, therefore decreasing the amount of pollution produced and decreasing the amount of resources that are being used elsewhere, by having, for instance, not having to mine for coal or drill for oil, and damaging those areas in the process. All right, so ladies and gentlemen, a little bit of a shorter video this time. I hope that it was informative enough, and if you have any questions, please feel free to ask them at any point, and I will get back to you as soon as I can. I have to cut it a little bit short. I hear my son crying upstairs. He just woke up from his nap, so I got to go grab him. But I hope everybody is doing well, and I look forward to the next time we talk. All right, thank you. Have a great day.